Okay, so let's talk about free energy and spontaneity. So spontaneity means will this reaction proceed on its own? If it's a spontaneous reaction, then yes, it will. So the variable that we have here, delta G, is Gibbs free energy. If delta G is negative, then this is a spontaneous reaction. If delta G is positive, then this is non-spontaneous. So if it's spontaneous, then this reaction proceeds on its own. It's energetically favorable. You do not need to put energy in. If delta G is positive, it's non-spontaneous, it is non-favorable, and you would have to put energy in to make this reaction happen. So again, just pay attention to those key words when you're reading word problems. If it says a favorable reaction has a delta G of 100. That would be negative 100 because it's favorable. If it says an unfavorable reaction has a delta G of 100, then that would be positive 100 because it's unfavorable. Spontaneous, non-spontaneous, favorable, non-favorable. You might hear those different terms. So there's two different ways that we are going to calculate delta G, and we'll talk about one in this video and one in the next. So the relationship of delta G to delta H and delta S, enthalpy and entropy, is delta G equals delta H minus T delta S. So we can also use this for the standard free energy. So we could say the standard free energy equals the standard enthalpy minus T times the standard entropy. So again, those are just standard conditions. Those are what are going to be published when you're looking up these values. Another thing to pay attention to again is the units. So delta G is going to be in kilojoules per mole. Delta H is going to be in kilojoules per mole. T has to be in Kelvin. Delta S is going to be in joules per mole Kelvin. So this is a big thing to pay attention to, is that delta S is going to be in joules. Everything else will be in kilojoules. Also remember what the signs of each of these mean. This is from the previous video, Gibbs free energy, introducing Gibbs free energy. Remember when you're reading word problems and they're giving you values, to pay attention to key words so you can determine if the sign of those numbers are positive or negative. Remember, the sign is showing you the direction that the energy is flowing. Okay, so let's look at an example. So let's use this same formula that we have looked at before with the oxidation of ethyl alcohol to acetic acid. So I'll write it out again. So here is ethyl alcohol, here is acetic acid, the oxidation of ethyl alcohol to acetic acid and water. So if I ask, you would be given, again, or could calculate the way that we've calculated delta H and delta S before. But let's just say I'm going to tell you, and you probably wouldn't be given the temperature, but because you see these degree signs, the temperature is always 25 degrees Celsius at standard conditions. So I usually will get questions when students are trying to do their homework and they're trying to do this problem and they say, I don't know how to do this because it doesn't give me the temperature. If you see these degree signs here, that means you're at standard conditions. Standard conditions is always a temperature of 25 degrees Celsius, which means the temperature that's going to go here is going to be 298 because it needs to be in Kelvin. So this is something that students usually get tripped up on, is because even though the temperature isn't given, if we're at standard conditions, it's 298 Kelvin. If these little degree signs aren't here and we're not at standard conditions, then they would have to give you the temperature. It would be at a different temperature. So I'm also going to tell you that the standard enthalpy of this reaction is negative 495.2 kilojoules. And the standard entropy of this reaction, we already calculated actually a few videos ago, we calculated the standard entropy of this reaction to be negative 136 joules per Kelvin. And we're just know that this is 298 Kelvin because we're at standard conditions. So I'm just going to plug these in and solve for delta G. The thing to pay attention to is that entropy is in joules per Kelvin, so I'm going to go ahead and convert this right away to negative 0.136 kilojoules per Kelvin. Or you could say 1.36 times 10 to the negative 1, negative. Okay, so I'm just going to plug it all in. Delta G equals delta H, negative 495.2 kilojoules, minus T, 298 Kelvin, times delta S, negative 0.136 kilojoules per Kelvin. And this is going to give me delta G, standard free energy of this reaction, is negative 454.7 kilojoules. So you'll see delta G either given in kilojoules or kilojoules per mole. This is the free energy for this reaction. So you could say per mole. It would be per 1 mole of the ethyl alcohol, 1 mole of the oxygen, 1 mole of the acetic acid, 1 mole of the water. And then you could use it as a conversion factor. If the question asked you how much free energy would it be for 100 grams of ethyl alcohol, then you could use this to say, well, this is the free energy for 1 mole of ethyl alcohol. Then you could use it as a conversion factor for that. So you'll see this given both ways as either kilojoules or kilojoules per mole. They both make sense. So we know how to solve for delta H. There's 3 different ways that we used to solve for delta H back in chapter 9, either experimentally or using Hess's law or using the delta H of the reaction. We calculated delta S using the delta S of the entropy of the reaction, and now we've calculated delta G using this relationship. Again, think about what this means. This is a negative number, so that means this is a spontaneous reaction. This means it'll happen by itself, which we said in a previous video. What this reaction really is ethyl alcohol is what's in wine. The bacteria that's also in wine, when it is exposed to air, so once your bottle of wine gets opened, the bacteria in there react with the oxygen. It oxidizes this ethyl alcohol to produce acetic acid, which is vinegar, and water, which is why if you open a bottle of wine and you leave it for a long time, it goes bad because the ethyl alcohol is being converted to vinegar. This is how vinegar is made from wine. Red wine vinegar is red wine that's been converted to vinegar. So this is a spontaneous process. You don't have to put any energy in for this to happen.